Hypothesis testing, testing a claim about a proportion. So in this section, these are the notation we're using. N sample size, P is the population proportion, P hat is sample proportion, and Q is 1 minus P. These are the requirements you always have to keep in mind while testing, doing the hypothesis testing using the proportion. The sample observation should be simple random. The distribution should be binomial distribution. And the condition n times p, which is number of sample size times the population proportion, should be greater or equal to p. So that is the requirement. Those are the requirements. And then after that, we can find out the sample test statistics by using this formula. This section is very, very, very similar to the previous section. Okay. So there are two different methods we can use: p-value method and critical value method. We can use the technology for finding those value, and then this is from previous section. As you can see, these are the tables. This is the formula we're using. And whatever we learned in previous section, we're going to do the same thing. But in this particular section, we're using proportion to do the hypothesis testing. And in next section, we're going to use mean instead of proportion. So whenever we try to find the test statistics in this particular section, we have to use this formula, and either we are going to use P method or critical value method, to make the conclusion. And depending on what we're going to find, these are one of the options we have for the conclusion. Okay, so let's look at some examples from this section. So example 1. Use the results from a survey of a simple random sample of 1,283 adults. Among the 1,283 respondents, 86% rated themselves as above average driver. We want to test the claim that 3/4 of the adults are rate themselves as above the average driver. And first of all, identify the actual number of respondents who rated themselves as above the driver. So as you can see here, out of 1,283, 86% of them rated above the average driver. So we can just find out 86%, which is 0.86 times 1,283. That's the number. If we round it to the nearest whole number, this should be 1103. So 1103 out of 1283 rated themselves above the average driver. So what is the sample proportion here? So sample proportion is out of 1283, 86%. So the sample proportion is P hat. This is the notation for sample proportion. It's a 0.86. Sorry, it's not 83, it's 86. So that's the sample proportion. And now for the hypothesis test, identify the value used for the population proportion. So as you can see here, the population proportion, we want to test the claim that 3/4 of the adults. So this is our population proportion. We use a symbol P for the population proportion, which is 3/4, meaning if you divide 3 by 4, it gives you 75%. So that's our population proportion. Okay, let's look at another problem here. Okay, a poll of 1,090 Americans showed that 47.2% of the respondents prefer to watch the news rather than read or listen to it. Use those results with a 0.01 significance level to test the claim that fewer than half of Americans prefer to watch the news rather than read or listen to it. Use the p-value method. Use the normal distribution as an approximation to the binomial distribution, normal distribution. So we need to use the normal distribution. As you can see here, normal distribution. So we can use this value for the test statistics. In this problem, let P denotes the population proportion of all Americans who prefers to watch the news rather than read or listen to it. So always for the null hypothesis is the population proportion or anything is equal to, in this case we want to find out the claim is fewer than half. So the population proportion should be 0.5, that is the half. and fewer than half means it's less than 0.5. That's the proportion. Remember, always for the null hypothesis there should be equality sign, and then alternate should be either less than or greater than or both. Identify the test statistics. For this we need to use this formula, as you can see here. So if you use that formula here, this our sample proportion is 47.2%. I'm going to use a calculator here. Sample proportion is 47.2 minus population proportion is 0.5. That's what we're using. Calculate it and divide it by square root of population proportion, which is 0.5, times 1 minus population proportion, which would be again 0.5, divided by sample size, which is 1090. You see that? And then close the bracket, and that will give you the answer for z value, which is negative 1.85 if you round it to the 2 decimal place, negative 1.85. okay, remember I just used this formula, and for this formula you just have to plug the sample proportion minus population proportion and then divide it by that square root thing. Identify the p-value for this g value. P-value means area under the curve to the left of this g value. So how do you find that? We can use a second distribution normal CDF function. It will calculate the area between, let's say, very small number. I'm going to take negative 1.00000 comma up to this g score, which is negative 1.85. It's going to give me area between these two number to the left, which is 0.321. So that would be our p-value, which is, if you round it to the 3 decimal places, it would be 0.032. That's the p-value. Now, as you can see here, the p-value is greater than what is this? It's a significance level. So that means when you try to make the conclusion, you have to use this one. If p-value is greater than alpha, fail to reject null hypothesis. So the conclusion is fail to reject the null hypothesis. So whenever you do that, look at here, you can use one of these options. So we're going to choose those options here. So look at here. Okay, start. Does the original claim contain the condition or equality? Is this condition or equality? And now if you go here, the claim is the proportion should be the null hypothesis is 0.5. That's the the claim. If you read it here, what is that? Use those result with the 0.01 significance level to test the claim that fewer than half of Americans prefer to watch. Fewer than half. So that means it's does the original claim contain the condition or equality? It's not equality, it's not condition, so it's no. Do you reject the null hypothesis? No. So fail to reject the null hypothesis. There is not sufficient evidence to support the claim. That is the answer. So there is not sufficient evidence to support the claim. Okay, let's go to the next problem. Consider a sample of 48 football games where 26 of them were won by the home team. This is the sample, and this is the significance level. To test the claim, this is the claim we are testing. The probability that the home team wins is greater than 1/2. So that's the claim, that's the alternating test. So what is the null hypothesis? Its probability should be equal to 1/2. So null alternating hypothesis is greater than 1/2. So this one is the right one. Now, identify the test statistics for this hypothesis test. As you can see here, the test statistics is, you can always find by using this formula, as I mentioned here, sample proportion minus population proportion, and divide by this number. So let's go here to this problem. What is the sample proportion? The sample proportion is, consider a sample of 48 games where 26 of them were won. So 26 out of 48, that's the sample proportion, minus the population proportion is 0.5 divided by square root the population proportion 0.5 times 1 minus population proportion again 0.5 divided by sample size, which is 48, and then that gives us the sample statistics, which is 0.58. That's our sample statistics, 0.58. Okay, now the p-value for this hypothesis test is we need to find out the area under the curve to the right of this g-score. So how do you do that? Go here again and then use the second and then distribution and then use the normal CDF function. It takes the lower z-score, which is 0.58, and comma takes the higher z-score, which is, let me just take one huge number, and it gives me the area between these two number, which is 0.281. If I round it to the 3 decimal places, that is my p-value, 0.281. Now, as you can see here, this p-value is greater than this alpha significance level. So whenever p-value is greater than alpha, it's failed to reject. It's failed to reject. Okay, so you can go here, failed to reject. Where is that? So failed to reject, there is sufficient evidence to support the claim. Go here and read this. If it fails to reject, the condition is hypothesis has it's not equality, so it should be this one, failed to reject. There is not sufficient evidence to support the claim. So as you can see here, failed to reject, there is not sufficient result. This one is the right option. Okay.